Hi everyone. We're looking at calculating the bracing required for this plan. The calculation is based on two wind directions, one for the long length of the building, the other for the short end of the building. The page number is listed here and you can find it in 1684.3. Our wind direction is noted for our first calc, being for the long length of the building. The length is 8 metres, the width is 4 metres, the wall height is 2700, the roof height from the top of the wall to the top of the ridge is 930 mil. We need to calculate the vertical area, the elevation, the wind is impacting. The method for this is half of the wall height plus the roof area. We have half the wall height. We have a height of 2.7. We times it by the length and we divide it by 2. Then for the roof area, we multiply the length of the roof by the height of the roof. Then we deduct half the base times the height for these two little triangles here. And this gives us a total of 16.38 square metres. We now use the table 1684 for the long length. Here we have 1684. We have it for the long length of the building, and it's a C1 classification. We have a 4 metre width of our building. We have a 25-degree pitch, and this gives us a multiplying factor of 1.1. So we multiply our 16.38 by our 1.1, and that gives us 18.01 kilonewtons of racking force on that elevation. Now what we'll do, we'll look at some bracing, which I think is that. There we go, we have some bracing here. Now the following are bracing types and the ratings for a maximum wall height of 2.7 metres. So if we start, type A bracing can withstand 0.8 kilonewtons of force. The minimum and maximum length in metres are shown here. They're 1800 to 2700. Type B bracing, just lift that up a little bit higher. Type B bracing can withstand 1.5 kilonewtons of force. Type D bracing can withstand 3 kilonewtons of force. Type G bracing can withstand 3.4 kilonewtons of force. Now this is ply. It's for 1.8 metres, which is 227 by 900 sheets. There are more bracing alternatives in AS 1684.3, but we're just sticking with these ones for the exercise. Our formula to calculate the number of metres of bracing required is the total racking force, which is 18.018, divided by the bracing capacity of the brace type that we select. Okay, so the brace type that we select to start with is type A, and it has a 0.8 capacity. So when we divide our total force by our bracing capacity, we find we need 22.5 metres of type A bracing. Our minimum and maximum is 1.8 to 2.7. We're going to allow 2 metres. We have 2 walls, 4 metres long, gives us 8 metres of wall to be braced. We divide that by 2 because that's the bracing unit length we're using, and that gives us 4 units of 2 metre bracing. We then multiply these 4 units by our 0.8 capacity, and that gives us 3.2 metres of wall, and this does not comply. type B. We have a 1.5 capacity. We just go through the same routine and we find that it doesn't comply. We then go to type D and it has a 3 kilonewton capacity. We go through the same process and we find that it complies. Then we then go to type G. The same process again, except this time instead of dividing by 2, we divide by 1.8 because that's the 2 sheet supply. We complete the calc and we find that it complies. The next step in the short end is the short end. So we've now completed the long end of the building. We go to the short end of the building and we go through the same process. Okay, so we find half the wall area. We have 2.7 by 4 divided by 2 gives us 5.4. Then we just have half the base times the height. That gives us a total of 7.26. And when we do 7.26, we then look over to our 60. We had a wall. We had a C1 classification. We had a wall length of 4 meters, and it was 25 degrees. Okay, so that gave us 1.2 multiplying factor. Okay, so we ended up with 8.72 kilonewtons of force. We then use our type. We just go through the same process again. We go through our type A. So it's 8.72 divided by our 0.8, and we need 10.9 meters of bracing. The wall is 8 meters long. We have 2 walls, gives us 16 meters of wall, and our bracing units are 2 meters long, so we have 8 units. 8 units times our 0.8 is 6.4 meters, so this doesn't comply. We then repeat the process. Type B brace, which is 1.5 kilonewtons, we do the calculations. Our type D, which is 3 kilonewtons, we do the process there, and then we come down to our type G, repeat the process there. This is a basic outline on how to use 1684.3 for determining the bracing requirements in cyclonic areas. We have an exercise that accompanies this, so hopefully you can just follow the format and everything will be good. Thanks.